This is day 23 of Advent of Cyber 2024, and this challenge is called You Want to Know What Happens to Your Hashes? Glitch has been investigating how Mayor malware funds his shady operations for quite some time. Recently, the Mayor disposed of various old electronic equipment. One was an old tablet with a cracked screen. Being an avid connoisseur of active and passive reconnaissance, who does not mind dumpster diving for the greater good? Glitch quickly picked it up before the garbage truck. Surprisingly, despite being in a terrible condition, with a cracked and hazy screen, the tablet still turns on. Browsing through various files, one PDF file that caught his attention was password protected. It is time you work with Glitch to discover the password and cover any evidence lurking there. So the learning objectives are to learn about hash functions and hash values, saving hashed passwords, cracking hashes, finding the password of a password protected document. Before we dive further, it is helpful to learn how passwords are saved in authentication systems. A long time ago, before security was a thing, passwords were stored in clear text along with the associated username. When the user tries to log in, the system compares the provided password for this account with the saved one. Consequently, if a user forgets their password, someone with enough access privileges can look at the table and respond with something like, "The password for Joe Blogs is ASDF1234. This was a terrible idea, especially since a database can be stolen and its contents leaked online. Unfortunately, users tend to use the same password for different services. Consequently, if an adversary discovers Joe Blogs' password from another service, they'll try it on Joe's other accounts, such as email. To protect passwords, even in the case of a data breach, companies started to save a hashed version of the password. For that, we need to use a hash function. A hash function takes an input of any size and returns a fixed size value. For example, SHA-256 creates a 256-bit hash value. In other words, SHA-256 sum file name will return a 256-bit hash value regardless of whether the input file is a few bytes or several gigabytes. In the terminal below, we demonstrate this with one file being 2.3 gigabytes and another being 13 bytes. So they run it on both of them and get the same size length. Therefore, instead of saving the password ASDF123 verbatim, its hash is saved. For instance, if MD5 is being used, then this would be saved. Problem solved? Not really. Firstly, MD5 is now considered insecure. Secondly, in addition to choosing a secure hash function, we should add a salt to it, a random string of characters, to the password before hashing it. In other words, instead of saving hash password, we save hash plus salt, hash password plus salt, along with salt. So consequently, when the user tries to log in, the authentication system takes their password along with the saved salt, calculates its hash, and compares it with the saved value. If identical, they are granted access. This makes the passwords more immune to a variety of attacks. Although it is recommended to use a modern secure hashing algorithm to calculate the hash value of the password concatenated with a random salt before saving it, reality is that not that shiny. In many cases, there are issues in the implementation, be it due to negligence or ignorance. In a recent story, a social media platform was discovered to have saved 600 million passwords in plain text for 7 years. Despite all the security guidelines warnings against them, in other words, passwords cracking is not over yet. On day 14, we saw how Mayor malware intercepted network traffic to eavesdrop on the village. Technically speaking, he was attacking the confidentiality and integrity of data in transit. Today we will explore how to view password-protected document. Technically speaking, we'll be attacking the confidentiality of the data at rest. One aspect of our security requires us to protect data, while it is stored on any storage device. So examples include a flash memory drive, smartphone storage, laptop storage, and external drives. If an adversary gains access to any such drive, we don't want them to be able to access our files. Protecting data at rest is usually achieved by encrypting the whole disk or specific files on the disk. On the other hand, encrypted storage and files can pose an obstacle for the good guys who are investigating a criminal case. Digital forensic investigators need to find a way to access the plaintext files to prove or disprove any wrongdoing. In this case, for his private investigation to succeed, Glitch must figure out how to access the encrypted PDF file on the disposed of tablet. Glitch needs to play an offensive security role to break the security of the protected document. Opening a password-protected document is impossible unless we know or can find the password. The problem is that many users prefer to pick relatively easy passwords that they can remember easily and then use the same password across multiple places. Have you ever wondered which passwords are most commonly used? According to one source, the table below shows the top 15 most commonly used passwords. Interestingly, many users have opted for QWERTY, the first 6 consecutive letters on a QWERTY keyboard. So that's the list. Of course, users might get a little bit creative and might replace a character with a symbol. They might append the current year, a memorable date, or a few random characters or numbers to the original word. Knowing that Mayor Mauer has a cat called Fluffy, some passwords we expect him to come up with are Fluffy Cat and Fluffy 2024, unless he uses his name or title and credits a password such as Mayor 2024. So for this challenge, we only need to start the virtual machine, as it will open up in split view. So enough learning about password storage and password choices. It's time to crack some passwords. We will cover the following: cracking a password found in a breached database and finding the passwords of an encrypted PDF file. Mayor Mauer had an online account in a now defunct forum that was breached, and all its user data was leaked. After checking online, we were able to retrieve the mayor's password in hashed format. It is listed below. We want to discover the original password. The first step in our approach is to figure out the type of the hash type function. Then we'll try to hash different passwords from a password list until we find a match. So we need to wait until this is finished loaded first. Okay, it's now up, so whereabouts are we? Okay, so let's clear this. We'll cd into AOC, and then we've got hash 1 there. But let's see what's in this. Okay, so it wants us to run the Python file hash ID and pass it hash1 txt. Apparently not found. Maybe I don't pass it as an argument. Alright, I'm meant to... Okay, so I cat hash1, I then copy this, then I run the Python, and I paste it into here. There we go. So a few possible types, but most likely SHA-256. So we'll now use the passwords from rockyou.txt to try find what the password actually is. So let's clear that. So using John the Ripper, John -- format equals raw SHA-256 -- word list equals user share word list, then rockyou, and we're passing it the file hash1.txt. So it doesn't seem like the password was found. So what it wants us to do is change the command so it tries things like replacing the letter A with the number 4. So we will do that, and you do that by adding -- rules equals word list, and we found Fluffy Cat 12. So Glitch has discovered Mayor Mauer's password used on the breached online forum. Although there is a high chance that this password will be used to access other online accounts created by the mayor, Glitch does not want to go that route, as it would violate the local laws and regulations. Instead of attempting anything illegal, he focused on the data he discovered in the mayor's trash. There's one interesting looking PDF file that happens to be password protected. You can help Glitch break it. The first thing you need to do is convert the old password protector file into a format that John can attack. Luckily, John the Ripper Jumbo Edition comes with the necessary tools. The different tools follow the naming style format to John. So if we do that command, opt John, and search for this. Cool, we've got a large list of stuff in here. Okay, these are all the John commands, that's what it is. So pdf to john.pl, private.pdf to pdf.hash. So I've now got pdf hash there, and I assume we're now going to be running the same John command we did before to break that original hash, but now it will be for pdf.hash. Okay, we need to change that command, but first, the first question: what was the hash stored in, or what was the password for hash1 txt? Fluffy Cat 12. And now we need to change the command for this. So change it to rules single, and then get rid of the format raw. Now we run it. Actually, we're meant to also change the word list being used. There's apparently a word list in this directory. So let's see if that works. So just word list.txt. And there we go, Mayor Mauer. But then we need access to the actual file. So we've got this command here we can use, which will convert the PDF to text. So we do this. Can't copy anything in. So PDF to text, private PDF I cleared the output. I don't have the password anymore. I meant to, so that file's no longer there. John show. Is this what it wants us to do? Okay, there we go. Mere malware. So let's should have copied that. There we go. Now PDF to text private .pdf. Then what's the flag? Dash up W. Now what did that do? Private txt. Cat private txt. Oh, let's grep that and do thm. Okay, apparently not. We will instead do head private txt. And there we go. THM, do not get caught. So that is all the questions answered. If you like this video, make sure to like and subscribe.